Hey guys, this is CHEMPLIFIED and today we will talk about Markonikov rule. Markonikov rule is one of the most important rules that we talk about in organic chemistry, and today we will learn what is the concept on which Markonikov rule is based. So without wasting time, let's start. So what is the statement of Markonikov rule? When an unsymmetrical reagent, let's discuss what is symmetrical and unsymmetrical. For example, this is a molecule. This is butane, simple butane. Now this, if there is a double bond in between, in the middle, then this molecule is symmetrical, right? This is 2-butene. Now if there is another butane molecule with a double bond at the terminal carbons, now this is unsymmetrical. So symmetrical and unsymmetrical simply means which show symmetry in the structure. This is unsymmetrical structure because the double bond is present in the terminal carbons, and this is symmetrical because the double bond is present in the middle of the molecule, right? So this is symmetrical and unsymmetrical. Now what are we talking about in our case is symmetrical, unsymmetrical reagent. For example, H2. If we are taking H2 as reagent, this is symmetrical reagent. O2 is symmetrical reagent. But if we choose HCl, this is unsymmetrical reagent because this molecule is polar molecule. So polarity simply gives you examples of unsymmetrical reagents. Now let's come back to the statement. When an unsymmetrical reagent adds to an unsymmetrical alkene, so the reagent is also unsymmetrical and the alkene which we are using is also unsymmetrical, like 1-butene. The positive part of the reagent attached to that double bonded carbon which bears greatest number of hydrogen atoms. Now what is the meaning of positive part in unsymmetrical reagent? For example, HCl. Now chlorine will acquire delta negative charge and hydrogen will acquire delta positive charge. Why? Because chlorine is more electronegative than that of hydrogen. So this becomes the positive part and this becomes the negative part in an unsymmetrical reagent. Now let's come back to the statement. The unsymmetrical reagent, the positive part will attach to that double bonded carbon which bear greatest number of hydrogen atoms. According to the statement, if we have this butene, now we add H plus. The H plus will attach itself to this carbon because it has 2 hydrogens with it and this has only 1 hydrogen with it, right? So according to the statement, the positive part will attach itself to that carbon that has greatest number of hydrogens. Either you can learn this statement or you can look for the concept which is used for Markonikov rule. So let's go for the concept so that you can remember it without learning the statement. Now the concept which we use in Markonikov rule is stability of carbocation. How is that? Let us again take a look at our butene. This is 1-butene. Now this particular area is electron rich, right? This particular area is electron rich. Remember that. Why? Because it has a double bond and the electron density at this place is higher than these two places, right? So this area is electron rich. Now an electron rich area will try to attract electrophile. Electrophile is that species that needed an electron to stabilize itself. Now in our case, let us take HCl again. In HCl, this is that delta plus charge and delta negative charge. Now if for some situation hydrogen get detached itself from Cl, it will have positive charge and chlorine will take over the electron and have a negative charge. So now this is your electrophile and this electrophile will move to the electron rich center, right? Now there are two possibilities. There are two possibilities. Either the hydrogen can attach itself to this carbon or hydrogen can attach itself to this carbon. This particular hydrogen can attach itself to either of the two carbons. But in the reaction, there are two products which are obtained. One is major product and the other is minor product. Now which one is major and which one is minor? This you will know by understanding the stability of carbocation. So let's talk about the stability of carbocation. This in front of you is the stability of carbocation. This is methyl carbocation. It is least stable. Now this is 1 degree, this is 2 degree and this is 3 degree, or also known as primary, secondary and tertiary, right? So tertiary carbocation is most stable. After that comes secondary carbocation and after that primary carbocation. Now this stability of carbocation decides the major and minor product. How is that possible? Let's take a look at that. We will understand the stability by taking an example of propene. This is N-propene. And here is our reagent HBr, hydrogen bromide. Now hydrogen have a positive charge, bromine has a negative charge, and this is electrophile and it will come to the higher electron density, that is the double bond. Now there are two possibilities. The double bond electron can transfer to this carbon or this carbon. The possibilities are shown by number 1 and 2, right? Now there are two different possibilities. We have already drawn the structure for those. Now look carefully. We are talking about carbocation. Now take a look at this carbocation. This is 2 degree carbocation, and take a look at this carbocation. This is 1 degree carbocation. Now in the previous slide we knew that 2 degree carbocation is more stable than 1 degree carbocation, right? 2 degree carbocation is more stable than 1 degree carbocation. So it all depends on the intermediate form. This intermediate is more stable because it is making a 2 degree carbocation which is more stable than 1 degree carbocation. So if the intermediate is stable, then the possibility of formation of this product, this particular product, is also high. So hydrogen will attach itself to this carbon, and the negative part, that is the bromine part, when it joins the reaction, it will attach itself to the middle carbon. Now if you read the statement again, let's go back to the statement. When an unsymmetrical alkene is treated with an unsymmetrical reagent, then the positive part will attach itself to that double bonded carbon which bear greatest number of hydrogen atoms. Now take a look at which carbon carries highest number of hydrogen atom. Now this carbon has 2 hydrogen atoms. This has only 1 hydrogen atom. The positive part, the H plus, is attached to which carbon? The carbon that has greatest number of hydrogen atom. Either you go with the statement or you go with the concept. In both the cases, result will be the same. So this will give you the major product. This will give you minor product. The possibility of formation of this is also there, but it is minor. The major product will be the product in which intermediate is a 2 degree carbocation. Understood? So this was it for Markonikov rule. The other one is known as anti-Markonikov rule. The only difference is the use of hydrogen peroxide or any peroxide. If we use peroxide in the same reaction, the product will be opposite. The major product will be opposite. This one becomes major and this one becomes minor. We will talk about that in the upcoming videos. So this was it for Markonikov rule. Thank you very much for watching. Have a good day.